want to spend some time kind of reviewing how we go ahead and solve equations by balancing. Just a quick question. You guys know an equation has what kind of a sign in it every single time?
An equal sign.
An equal sign. Something on the right has to equal something on the left here. Okay, does that make sense to you?
Yep.
Okay, so that being said, what we want to start looking at doing here today, guys, is go ahead and solve equations connected to some geometric figures and by balancing. And a lot of the stuff you're going to hear me talk about today is this. You're going to hear me say, I want you to, here's the phrase I'm going to use, undo stuff, all right? So if I start talking about undoing stuff, I'm going to hear, or you're going to hear the word inverse a little bit. And what that simply means is this. I'm going to ask some questions like, guys, when I get to this step right here, we have addition. So how would I undo the addition?
Subtraction.
So I would say the inverse of addition is
Subtraction.
Or I might say, guys, we're right here, and there's some S's, but a lot of subtraction going on. If there's subtraction going on, I would say, what's the inverse of subtraction?
Addition.
Addition. So to undo it, you're going to add. How about multiplication? What's its inverse?
Division.
Division. And how about division's inverse?
Multiplication.
Multiplication. Okay. So let's get some things established right here. First of all, what is an equation? How about a volunteer to read this for me, please? Raise your hand. Go ahead, Shares.
A mathematical statement in which one expression equals another.
So we have to have an equal sign. One expression equals another. So you've seen stuff like this. I might, as an example right here, these will be my example column. Or this will be in my example column. I might have something like 2x plus 7 equals, I don't know, 15 right here. By the way, just real quickly, does anybody know the answer to that off the top of their head?
Yeah.
2 times some number plus 7 equals 15? Anybody know it?
No, because you don't know the numbers.
Don't know the number. 4. Who said 4? John, yeah, 2 times 4 would be my what? 8. And 8 plus 7 would make 15. Yeah, 4 would work. Okay. So yeah, that's pretty good. That's pretty good. All right, so an equation. One expression on the left equal to another expression on the right. That's typically how you're going to see that. Typically, one expression is a variable expression. The other one's numerical. At least in this section, it will be. How about a solution for me then? How about a solution?
What's that?
Well, somebody want to read it for me?
Value of a variable that makes the equation true.
So in this example right up here, we said, you know what, if I plug 4 in for x, in other words, go 2 times 4 plus 7. What was the 2 times 4 here, gang?
8,
And then add 7. Where were we?
15,
Okay, so what would I say my solution is? I would say my x value has to be what value?
4.
4. Basically, 4 is the number you plug in to make the statement or the equation true. Okay, so that's all a solution is. What number are you going to plug in to make this true? And I'm sure you've talked about this a little bit before. Okay, solving an equation simply says process of finding the solution to an equation. This is where the word undo stuff is going to come into play. So you're going to do a lot of undoing, or you might see the word inverse somewhere. Okay, undo stuff where there's a lot of inverses, okay? Equivalent equations. Equivalent equations are equations that have the what?
The same solution.
So I have an example right here. If I had x plus 4 equals 6 like this, what's your solution to this? What plus 4 would make 6? 2, okay? And then if I had something like this, if I had something like x minus 2 equals 0, what would the solution be there? In both cases, the solution for this would be x equals what? Okay, so since both of those equations require x to equal 2 to make that true, then we would call these what kind of equations? Equivalent equations, because they have the same what? They have the same x value, or the same solution, okay? Okay, gang, terms-wise, are we okay with that? Any questions about what's up there terms-wise? All right, well, let's go ahead and move forward here quickly. At the bottom here, this is really important, rules to solving equations. Rules to solving equations. Boom, 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 boom. Rules to solving equations. What's the first thing say to do?
Combine terms on both sides.
Combine terms on both sides if possible. When I say combine terms, I'm talking about combining like terms. So for instance, guys, you might have something like this, 3x plus 7x equals, I don't know, 100. Just take a look at the left side right here, guys. Just looking at this right here, there's two x's in here right here, but it says 3x plus 7x. Based on the last section, is there something you could do with the 3x and the 7x? Combine them. What's that 3x plus 7x going to be? 10x. So realistically, I can say, you know what? I can say this is the same as 10x is equal to what? Well, 10x is equal to 100 here, right? What I did was combine the 3x and the 7x there. Okay? Make sense?
Yeah.
Makes sense? Okay? If there's any terms to combine then, what's the next thing it says to do? Undo any addition or what? Okay, after you've undone your subtraction or addition, and you know what the inverses of each are, okay? After you've undone any addition or subtraction, what's the last thing it says to do here? Or undo, if you will.
Or until the variable is all.
Okay, so you're going to undo multiplication, division last until the variable is all alone, okay? This is your roadmap. This is very important, all right? You might want to put a star by this. This stuff here, very, very important, okay? And honestly, this is going to be your roadmap for every problem we start looking at. I'm going to ask the questions. Any terms can combine on either side? No. Any addition or subtraction, take care of it. Maybe yes. Any multiplication, division, take care of it. I don't know. Let's start looking at some examples, okay? So let's look at some examples and see what we can come up with. All right. Any questions on the first page? Anyone? Where's Jaden at? Did you come in yet?
Nope.
Somebody go get him. I thought I told somebody to get him. Go get him. Okay. Somebody put some notes on this page. Huh? I told someone to go get them. Who did I tell to go out and get them?
No, actually, that's
I told somebody. Oh, okay. You got notes already? You have notes already, James? All right, kiddos, here we go. Second page. All right. So an example right here, gang. An example right here. How do you undo addition? How do you undo addition? Subtract. Okay, so here's the situation. We undo addition by subtraction. So suppose I've got an equation like this. It's x plus 4 equals negative 12. All right? Our job here is to isolate x, figure out what it's equal to. Now, guys, take a look at the x. What are you doing to x?
Adding it.
You're adding a 4, right? Okay? So I want to get this x all alone right here. What I like to do, guys, is draw a line just like this. Kind of split that up. You don't have to do that, okay? But guys, to the left side right here, I would like to get this x variable all alone. And to that x, you're adding how much? 4. You're going to have to do what? If I want to get rid of this addition of 4 so x is all alone, what do I have to do to both sides? The opposite, subtract 4. So my solution here then, if you think about it, guys, what's a plus 4 and a minus 4 really do to each other? Aren't they opposites of each other? They kind of cancel each other out, don't they? Okay? This and this, gone. All right? How many of you guys play that cornholing game they call it, or beanbags game? You guys ever say, oh, we canceled each other out?
Yeah, it's called bad.
It's called cornholing, if you will.
Well,
We call it beanbags. In my neck of the woods, I am the champion of beanbags. And anybody wants to come to my territory and play me, I will destroy you with a capital B. Promise. Is that a challenge right there? Anybody want game? Who's got game?
I do.
Bring it, chumzillas. All right. Here we go. So my solution is simply going to be negative 12 minus what, guys? Negative 12 minus what? There it is. Negative 12 minus 4. What's my solution here? Negative 16. So x equal negative 16. All right. Simple, right? Simple, right? Okay. Next one, an example to undo subtraction. Suppose you had something like this. Maybe 16 equals x minus 10. Okay, guys, your variable's on the right this time. You're subtracting 10. I want x to be alone. So we have to undo that operation of minusing 10. What do I have to do, Hannah? Add 10 to both sides. Good. And keep in mind, if I do one thing to one side of the equation, you have to do the same to the other. Okay, so again, I think we're pretty good at this stuff. It's going to get more complicated though. What are the 10s going to do on the right side here, kiddos? Left with a variable over here then, which is what? So from this, I'll write it over here. We'll say x equals, what are you going to have on the left side? 26, aren't you? Right? How you guys feel about that? You guys okay with that? Again, how do you undo the subtracting part? You add. So what if I had, listen to this, x minus 4 equals 10. X minus 4 equals 10. What's my x? Oh. 14, right? X minus 4 equals 10. 21. How do you undo multiplication? Divide.
Is that an 18 or 10? No, it's a 10.
10.
16 and then under 16 equals x minus 10.
16 plus
Oh,
10.
duh.
26.
I got it.
Good. Okay, undo multiplication. Here we go. Suppose I've got like 3x equal to 33. Guys, anytime there's a number right next to the variable, what operation is implied? Times, right? How are you going to undo multiplication of 3 here then? Yep, I want to get this x alone. We're taking it times 3. So I just draw a line here to divide. You got to do it to both sides. Guys, a 3 over 3, what's 3 divided by 3 really equal? 1. So that's really 1x then on the left, isn't it? Which I can just express as 1x like this. So in essence, the 3's in division really do what to each other? What's the word I'm looking for? Cancel each other. Good. What's my solution here, kiddos? 11. Okay. Quickly look at 1. How do you undo division? Circle that. Everybody with me so far? Yay, nay, maybe? Yeah? Okay. Well, look at this division part. How am I going to undo division? I might have something like x divided by a positive 4 equals negative 6. In other words, some number divided by 4 is negative 6. Okay? To get x alone, well, we got to undo division of how much? Got to undo the division of how much? 4, right? Got to undo the division of 4. So inverse of the division is, yeah, so we want to multiply both sides by 4. Multiply the left by 4. Multiply the right by 4. What's going to happen to the 4 by 4s over here? They're going to cancel, all right? So your solution from this, x is going to equal what value? Yeah, that negative 6, the product of negative 6 and 4 would be negative 24. And guys, I'll always encourage you to do this, even though I haven't discussed it yet today, but go back to the original problem. Does negative 24 divided by 4 make negative 6? It does, doesn't it? So can't you check stuff that way?
Yeah.
All right. First 4 are pretty easy, right? First 4 are pretty easy, right? What happens if I run into a multi-step? Oh boy.
You have to multi-step away.
All right. This is the part right here where you might want to refer back to the front page, okay? I might have something like this. 6x minus 2 is equal to, oh, how about 16? Okay. Guys, there's various operations happening up here with the x. You're taking x times what first? 6. And then subtracting what? 2. And that equals 16. Now, guys, if you go back to the first page of your notes. Haley, can I borrow this quickly?
Yeah.
If I go back to the first page of my notes, it simply says here at the beginning, guys, and giggles, it says, combine the like terms on either side of the equation if possible. Okay? So just looking right here real quickly. Hang on one second. Let me see if I can find something here. Oh no. This is pretty cool. There's the right side of the equation right there, right? The 16. Can I combine that with anything right now? Just looking at just that side? Can I combine anything there? Answer's what? No. Okay, take a look at my other side. Here. Take a look at this other side. How about this one? How about 6x minus 2 on the left side? Can I put those together at all?
No.
No, you can't. So, what I do then is this. First step, there's nothing to do. So what's step 2 say on that front page of your notes? If there's nothing to combine, undo what? Addition or subtraction. Is there any addition or subtraction going on up there next to X?
Yeah, there's subtraction.
There's subtraction. So what are we going to have to do, Hannah Woods?
I don't know.
What's the inverse?
Oh,
Add how much, kiddo?
2.
You're subtracting 2, so we better undo that by adding a 2. All right, so help me out. On the left side, what's the negative 2, positive 2 going to do? Cancel. So what are you left with as an expression on the left side now?
6x.
Okay, so this becomes the following. It becomes 6x on the left because the negative 2 and positive 2 simply canceled. Then what's that going to equal on the right when you have the sum of 16 and 2? All right, so we've undone any addition or subtraction, so I'm down to that third step. Any multiplication or division's a deal. Got to divide by how much? And when I divide both sides by 6, what's our solution, gang? Show of hands in the air before I turn around. How many say, yeah, I feel pretty good about this? Less than half? Getting there half? Some of us are still right. Looks like a majority. Okay. All right, number 6, another tough one. Let's talk about this one. What happens when we run into situations like this? For instance, ooh, I like this problem. 6x plus 4x minus 3 minus, let's go 3x, maybe equals 7, 3, and how about 18? Okay. Cover this up again here. Guys, looking at the left side of my equation right here. There's the left side of the equation. Is there anything I can put together to simplify that left side?
6x plus 4x.
I can put some x's together right here, right? I can put an x together here, here, and here. Keeping in mind what kind of x is this right here?
Negative.
Okay. What would the 6x plus 4x make? 10x, and then 10x minus your 3x would be 7x. So the parts that I've underlined would simplify to 7x because those are like terms. Cross them out. What part of the expression still remains on the left side? So behind that I have to write what? Minus 3. What's this still going to equal on the right side then? What value? 18. Okay? Do you guys understand from the first line to the second line how I took steps to get my left side in simplest form? Everybody okay with that? Can you tell a difference, Mr. Fleshner?
A little bit, huh?
Oh boy, it's nice.
Read it back here.
It is nice.
So we'll just have to keep playing with some settings. You get the way you want.
I think it's pretty much
The way you want.
gold. Have 20/20 vision now? Awesome. Thank you so much. Hey, I'm like a little kid at Christmas today, just so you know.
Perfect.
All right, next step right here. Where are we at? What do you guys want to do?
You gotta add 3.
Add 3 to both sides, okay? I'm running out of room. You guys take a minute and finish this up. Tell me what your solution is. I'll do the 3, the plus 3. Okay, does anybody have a solution yet?
3.
Christian?
X equals
3. So the negative 3, positive 3 would cancel. I would have 7x is equal to what? What's the sum going to be on the right? So you've got 7x equal 21. Do you guys agree 21 divided by 7 is my solution then?
Yeah.
3. Very, very good. Okay, well, let's see if we can't figure some stuff out knowing these properties, all right? Everybody have everything down so far? I love my new TV. We're going to watch March Madness.
Yes.
Watch the Hawkeyes throttle some
Is
teams
that all
this
we're
year,
gonna do?
hopefully.
Gary Mark? Like,
Pearson, I've already given you a little bit of an assignment. You don't want more. All right?
How do you get the x equals 3? Oh, never mind.
21 divided by 7 there.
Yeah.
All right, let's roll on to the next page. Let's see if we can't do some stuff here. What I would like you guys to try to do is solve those on your own real quickly. Take a minute, solve those on your own. Once you've got a solution, check with a neighbor around you, see if you agree. If you disagree, make sure you talk about it, okay? We need more time with those. Yeah, Bo. 623. And it's 39 through 50. Again, check with a neighbor.
Even if we know it, it's just for our form, it's for Brady.
No.
Even if I
Good, that's good. I'm not too concerned now, but when we start looking at multi-step and stuff with distributed property on one side and the other, then you're gonna wanna start.
You don't know that?
All right, real quickly, let's run through these. Hey, first one, I'm not so concerned about throwing the answer out there, but talk to me process-wise. What's your process in the first one? What do I have to do? What do I have to do to both sides on the first one? Subtract 6, all right? Subtract 6 both sides. Do you guys get x equals 18 in this one?
Yeah.
All right, how about a solution in the next one? What'd you guys get? X is negative 6. You got that by taking negative 18 and
Dividing it by
divide by 3. Very good. Next one is a little more difficult. Multi-stepper. Do I undo the multiplication or addition first? So I got to subtract how much? Subtract a 4. Okay, so on the left side, the 4s would cancel here and here. I would have 2x equals 16 minus 4 on the right is, so then I go 12 divided by, and your value is positive 6. Very good. I think you guys have got this down, all right? Let's run through a couple of examples involving perimeter. Get you a short, quick quiz, and we'll get you on your way for the weekend, all right? Guys, this next one right here says geometric example. It says the perimeter of a figure is 70. Find the value of x, okay? First of all, what kind of shape does this look like?
Rectangle.
What's the name? We've talked about it. Starts with a P.
Parallelogram.
The parallelogram. If I call this distance maybe x right here and this 12, and that's all I give you and I tell you that is a parallelogram, what's it imply about the distance up top?
It's probably
Parallelogram.
It's x.
It's x. It's the same as the bottom. If I tell you the right side's 12, what's that make the left side? 12. Okay. Guys, the key word or the operative word up here says the perimeter is what? Okay. So what it would mean is this. I could write an expression on the left for perimeter. My expression on the left for perimeter would be the following. How many x's to add up here?
70.
Well, but now wait a minute. Listen to my question. Not everyone's listening, okay? How many x's do I have here? If I would add the two x's together, you would get 2x. 2x plus, okay, let's go. Don't I have a 12 and a 12 to add up also? That would be a plus 24, wouldn't it? So do you understand my expression for the perimeter? As perimeter is defined as the sum of all sides of a polygon. Okay. All right, then they tell you right here, gang, they say, you know what? The perimeter adds up to how much? So what am I going to set this equal to? 70. Okay? So, what's your next step? Subtract what? So I've got 2x plus 24 equals 70. I got to subtract 24 from both sides. And this becomes 2x on the left because the 24s cancel. What's the difference of 70 and 24? I believe it's 46, isn't it?
Oh, yeah, sorry.
You're ahead of me, Hannah Woods.
Yeah.
I'm a little slow at this age. You got to wait for me, all right?
And that equals.
So what are you going to do with the 46 now?
Take 2 from each side. You're gonna
Take
divide
2 or
it.
divide everything by what?
2.
Okay, so we take 2. The operation I'm looking for is to divide by 2.
Is
23.
X equals.
And your x value would be 23 when you solve this. Okay, how do you feel about that?
Good.
Here's one for you. I said find the measure of the unknown angle in the triangle. Suppose I tell you this symbol implying what? What properties do you know about angles of triangles? They all three add up to 180, don't they? Okay, let's see if you can just talk about this mentally. Look at that triangle right now and say, hey, what's the x value? Can anybody do that right now? Christian? Close, really close.
It'd be 50.
I heard 50. Should be 50. Think about it right here, gang. All three of these angles have to add up to how much?
So how do we set that up though?
I'm going to show you right now. Okay? I've got one angle which I'm going to call x, plus the second angle down here labeled as 40, and the assumption on that bottom left angle is that that is how many degrees? Well, it's not an assumption. It's defined right here. It tells you that it's a right angle, doesn't it? So plus how much? Plus 90. And then by definition, for the sum of the angles of any triangle, that has to add up to what value or what measure? 180. Okay? So take a look at this with me here. I'll split this here. What would the 90 and 40 combine to on the left side right here?
130.
So I would say x plus 130 equals what? Well, it's still equal to the total sum of what? Okay, so when I take the step to combine those constant terms, you now have x plus 130 is 180. So if I want to get x alone, how are you going to undo your addition? Subtract both sides by what value? Good, gang. Very good. I've got x equals what value? 180 minus 130, what was it again, Christian? 50 degrees. Kiddos, what questions have you got for me today? Any questions? I have two comments for you. Number one, you're going to peel the quick quiz out of your notes and get that done. Turn that in to me today. Secondly, that book page that I gave to you earlier in the hour, page, what was it, 623? 39 through 50, you know is due when? Tuesday, okay?
Mine's this on this.
I'm sorry? I don't care, yeah. But just make sure you tear that quick quiz out of your notes and hang on to your notes.
Carson?
Yes.
Number also.
Have you sat the whole hour without a pencil?
Use mine.
Oh, come on.